Hey everyone, and welcome back. This is Unit 5 of Geometry, and we are starting our unit on trigonometry. So in trigonometry, you're going to see, basically a little bit more algebra coming into this, as well as all of these properties that we've been talking about with triangles so far making a reappearance. So trigonometry kind of does take a lot of the topics we've done already, plus some Algebra 1, and kind of mash it all together. It's a very intimidating sounding name. Like, it sounds like it's going to be a very difficult branch of math or something like that. I promise you it is not that bad. And a lot of you are actually going to find you really like this unit compared to previous ones because it reminds you a little bit more of algebra, which maybe was a strength of yours. All right, so goals for today. We are going to look at right angle triangles. And then we're going to start seeing, okay, what is this relationship between the sides and the angles of triangles? Because up until now, those have been two very separate ideas. So we're going to look at, okay, how are they actually related to one another? There's this thing called SOH CAH TOA. What is it? How does it work? What does it do? We're going to dig into that. And then we're going to actually solve some problems today as well. So we're going to solve for some missing sides and missing angles in right angle triangles. So questions for today: what is trigonometry? What are the relationships between sides and angles? And how do I solve for missing sides and angles? All right, so trigonometry, guys, is the branch of math or the branch of geometry where you're going to look at the relationship between sides and angles of triangles. So as opposed to in congruent triangles where we were proving angles were congruent, or we're proving sides were congruent, or similarity where we had dilations coming into play, we're now actually going to combine the two. So we're going to say, okay, we can solve for missing angles using sides of triangles or vice versa. All right, so let's just kind of recap on everything we know so far. So in terms of the angles of a triangle, what do you know? You know all three angles add up to 180 degrees, so they are supplementary to one another. We know that if there is an obtuse angle in a triangle, the other two angles must be acute. If there's a 90-degree angle, the other two angles are going to be complementary, so they'll add up to be 90 degrees. We know that the largest side of a triangle is opposite the largest angle of a triangle. Smallest side is opposite the smallest angle, and middle opposite middle. With the sides, kind of that same proportion with the angles. Biggest side is opposite biggest angle. We know that if you know two sides of the triangle, the third side cannot be bigger than the two known sides added together. So the sum of the two sides we know is going to be the max that the third side could be, so it has to be less than that. And if you subtract the two sides we know, the smaller from the bigger, the number you get is the smallest that third side of the triangle could be. So it's got to be a range between the difference and the sum of the two sides we know. Relationships of angles to sides, we kind of talked about that. Bigger side is opposite biggest angle. In similar triangles, we knew that the angles stay congruent, but the sides were all proportional by a scale factor. In congruent triangles, all three angles, all three sides corresponded to congruent sides and angles in another triangle. And then right angle triangles, we knew we had things like Pythagoras' theorem. We could solve for missing sides by squaring two sides to find the hypotenuse, or if we knew the hypotenuse on one side, we could find another one. The HL criteria for congruent triangles came into play. Two angles are complementary. One is a 90-degree angle, and geometric mean was something that we could do to find the altitude of the triangle from the hypotenuse to the right angle if we had the given measurements needed. All right, so just right angle triangles, just recap on that. Angles up to 180, one is a 90-degree angle, the other two are complementary. The longest side of a right triangle is the hypotenuse, and it's across from the right angle. And we can find any side length if we know two of them already. And area of a right triangle is half of the base times the height, and that A and B are perpendicular to one another. So base and height, they don't necessarily have to be on the bottom and the side of the triangle. They could be any two sides as long as they are perpendicular. And then geometric mean, you take the altitude, which divides the hypotenuse, and the division of the hypotenuse, you multiply those two and get the square root, and that gives you your altitude. Okay, so just thinking similar right triangles now, what do we know? So this is getting a little bit more specific. So you imagine we've got a right triangle, and we know it's similar to another one. What would be true? Well, they would both have right angles. We would know that the side length would be different, but it'd be proportional by a scale factor. Same thing with the other three sides as well. So the three sides will correspond to another one. And angles will be congruent. So yeah, pretty much like same stuff. Not much changes with right angle triangles for similarity, but what we're going to notice now when we do a little bit about trig, it's going to be very much about similar right triangles. So if we were to say that this side was 10 and this side was 5, and I told you, well, that means this side is going to be 20, you would tell me the missing side down here was 10. So same scale factor. So what you'll notice is that if I were looking at this angle and I took the side opposite it and the side beside it and I divided those, 10 over 20 is the exact same as 5 over 10. So the relationship between the sides is also proportional, and we kind of knew that from our triangle proportionality theorem as well. Sine, cosine, and tangent. So these are three words that shouldn't really have popped up yet in any math class you've taken unless you've already been in Algebra 2, and they are functions. So what is a function? Thinking back to Algebra 1, you're probably thinking something like f of x. And you're like, all right, well, what is that? So remember, a function is a set of rules that an input, bonus points, you remember, word for input, that is our domain of a function, goes through, so domain is the x, goes through the function, and out pops y, which is your range. So input, rules that are going to determine it's technically a transformation or a change of some sort, and then the range that pops out. So sine, cosine, and tangent are all functions. They're all rules that are followed that actually define the relationship between an angle of a triangle and its sides. So there is a rule to follow. So we know if you take one side of a triangle divided by another, there's going to be something true about the different angles of a triangle. So like we already said, well, the bigger the side, the bigger the angle is going to be across from it, but how much bigger? Or, if I know two of the sides and that other angle, can I figure out how big these angles actually are? And the answer is yes. So we're going to be able to do that by the end of this unit. We'll start off with right angle triangles, but we will eventually venture into triangles that are not right angle as well. So in right angle triangles, let me clear that. So in right angle triangles, we can calculate the values of the angles by using proportions. So the way in which the sides are divided or related to each other, that is going to dictate the angle measure in a triangle. All right, so before we move on any further, you're going to need to be able to use sine, cos, and tan on a calculator. Reason is it's a function, and it's a very complicated function, so it's not something that you're going to just be able to calculate by hand. It is possible to use trig tables. So if you Google trig tables, you will get a very long, 2-page, very ugly looking table of decimals that you can use if you need to. I would just recommend either pulling up a calculator on Google. Your phone can also do this. It's the scientific calculator though. So if you're using an iPhone, that's when you turn the phone horizontal and more options pop up. That's where you'll find sine, cos, tan. Android I'm not too familiar with, but I'm certain that it exists somewhere. You can also download TI-83 emulators for your phone, so you can get basically a graphing calculator into your phone if you need it. If you have a TI calculator or a CASI or anything like that, you should be able to find sine, cos, and tan as well. So just take a moment and actually locate where those buttons are. Whatever your device is, make sure you can find it and use it. Second thing, we are working in degrees. So there are two ways of measuring angles, degrees and radians. So make sure that your calculator is set to degrees. On a TI calculator, when you go into mode, that is the third row. So you basically get radian and degrees side by side. You want to make sure that the box is around degree. So that tells you that it's been selected. All right, abbreviations, just in case you need it, sin, cos, and tan. I usually pronounce it still sine, cos, and tan, but whichever way you want to pronounce it is fine. Just know that I will be abbreviating most of these from now on. All right, so in a right angle triangle, we're already familiar with this idea of a hypotenuse. And you've heard me probably say like the angle opposite a given side. So opposite shouldn't be too crazy a word, and then adjacent, just means beside. So if we were to think across, beside, longest, those are kind of words to keep in your head. So in a right angle triangle, hypotenuse is the longest side. We're like, okay, we got that. Should know that by now. If we move to same triangle, but we say, I want to talk about angle A, or I want to solve for angle A, or in relationship to angle A, there is an opposite side of the triangle and there's an adjacent side. So you guys should already be pretty familiar with opposite being across. So we should be able to identify the opposite side to an angle. The hypotenuse is always going to be across from the right angle, so it's always going to be opposite the right angle. And then the adjacent is the one that is not the hypotenuse, but is beside the angle. It actually touches the angle. It's one of the arms of the angle. So the adjacent is the one beside it. The opposite is the one across from it. Now, why do we have to highlight angle A? It's because these two sides change depending on which angle we are talking about. For example, if I flip to angle B, now the opposite and adjacent are also going to change. The adjacent is now side BC. The opposite is now AC. And this is one of the harder parts for this particular unit and this particular lesson, is being able to identify your opposite, your adjacent, and your hypotenuse sides. And if you're struggling with this and you find you're struggling with it, I really need you to work hard on being able to identify those. And that just comes with practice. So you take a bunch of triangles, maybe ask somebody to just highlight one of the two acute angles, so not the right angle. So we're only going to ever use this to talk about A or B. And you say, all right, can you highlight one of the angles? And then you have to identify the opposite, adjacent, and hypotenuse for that particular triangle. And just do it until it becomes natural. You're like, okay, I got this. So why do you need that? Well, there's this mnemonic. So it's called SOH CAH TOA. So this is just simply a way of remembering which function uses which sides of a right triangle. And say it in a fun accent, say it really loud, soft, whatever you want, something that's going to help you remember SOH CAH TOA. So what does it mean? If you had, let's just sketch a quick right triangle. So if we have an angle, and this symbol, by the way, if you're not familiar with it, is the Greek letter theta. So when you think about math and particularly geometry so far, we've had small letters to represent sides. We've had large letters, so sorry, uppercase letters, not large letters, uppercase letters to represent the points on a shape. You'll sometimes, or in our case often, this unit see Greek letters used to represent angles. So it's just, we needed a third set of symbols, so we went to the Greek alphabet. So in this particular mnemonic, SOH, SOH, sine of the angle is equal to the opposite side divided by the hypotenuse. So it's actually a fraction. So the sine of the angle is going to equal the opposite divided by hypotenuse. So if A was our angle, it would be sine of angle A, so whatever the degree measure of angle A is going to be equal to the opposite side. So in our little diagram over there, that'd be little a over the hypotenuse, which is lowercase c. Why is this important? Well, it's an equation, first of all, so this allows us to solve for things. So pretty much one of these three values is going to be missing, and you're going to need to solve for it. And you have two pieces of information, you're missing one, you can solve any question like that pretty much. Cos of an angle. So if we were looking at angle A again, cos of angle A is the adjacent. So the adjacent side to angle A is B over the hypotenuse is C. And tan of angle A is the opposite, which is A, over the adjacent, which is B. So you can kind of see, all right, this is, I know, very new. It's going to take some time to kind of get used to SOH CAH TOA and how we use it. Give yourself a little bit of grace in terms of, all right, this is something new. I'm not expected to know it, understand it first time I see it, but I'm going to refer back to the slide. This should be in your notes. Like if you're taking notes, this should be in your notes. I'm going to refer back to this a lot in the coming days as I get used to how these functions are going to work and how I can use them to solve different problems. So don't expect perfection day one, but this is something I do need you to work on a lot to try and make it. All right, so let's just look at tan for a second. So we know the hypotenuse is AB. If we're talking about tan of angle A, so A is the one that's highlighted, the opposite is BC, the adjacent is AC. So I didn't need to write those. So if I were to scale this triangle, say like I was to dilate it down, still right triangle. So right angles are the same. Angle A is reflexive to itself. So these triangles, the little one in here and the bigger one that we start with are similar by angle. So similar triangles. That would mean that the opposite side of this triangle and the adjacent side of the little one will be proportional to the original opposites and adjacents. And you saw in my first example, I'll give a different one. So say this one is 8 and this one is 2. And the original side length was 4 and the new one is 1. So this is a 2, by the way, not a 20. The opposite divided by the adjacent. So tan A on the big triangle would be 8 over 4. Tan A on the little triangle would be 2 over 1. And just kind of be simplified, you get 2, simplify, you get 2, you get that same proportion, same relationship. So the angle A will end up being the exact same measure, which, duh, we just said they were similar triangles, so they should be the same. So let's just look at a very basic, but an example that's going to come up a lot. You've got a right angle triangle, so you can see angle C is a right angle. Angle A is given to you as 40 degrees. The opposite side is X. The adjacent side is 10. And we're being asked to solve for the value of X. So the reason why this is a tan question is the two sides we're working with is the opposite and the adjacent. The opposite is the one we want to find, the adjacent is the one we're given. So you would go back to SOH CAH TOA. You'd be like, okay, opposite and adjacent, that goes with tan. So tan is the function you would choose to work with. That's the hard part as well. If you choose to try and solve it using cos or sine, you will often get an answer. It's just the incorrect answer because it assumes you're looking at a different triangle. So this is why it's really important to make sure you can identify your sides and then which function goes with it, because you can get a wrong answer and not realize it's wrong. Okay, so the tan of the angle is equal to the opposite divided by the adjacent. Fill in what we know. The angle is 40, so you don't have to put the degree symbol in anymore. The opposite is X, the adjacent is 10. And now it's just an algebra problem. How do you solve for X? When X is divided by 10 to get X on its own, you multiply by 10 on both sides. And that will cause 10 divided by 10 is 1, so you get left with X on its own, and you get 10 tan 40 on the other side. At this point, you pull out your calculator and you solve it. So I recommend to you guys, don't solve for tan or sine or cos, whatever it is, until you are ready for your final answer. Leave it in tan 40 form. Reason, almost all of our trig functions are going to result in irrational answers. Like they're going to be decimals that will go on forever. They're not all irrational, but a large proportion of them are. So if you solve tan 40 too early, you will have to round it. And every step that you do in your equation after you round kind of amplifies the error or the rounding error that's going on. So the later you wait to calculate and round, the better. So my calculator, I do 10 times tan 40, And let me see what that was before it rounded. So 10, 10, 40 is 8.3909. So like it was 8.390996312. So long decimal, we're going to be rounding to usually hundredths or thousandths in this unit. And in this case, it was hundreds, so it would have been 8.39 is the value of x. So at this point, you could say, all right, I know 10, I know 8.39. I could solve for the hypotenuse using Pythagoras' theorem if I wanted, or I could pull out a different trig function to solve for the hypotenuse. So just say, for example, the question asked us, let me kind of ditch all of this. Say the question asked us to solve for y instead of x. So like this was gone. And you would say, all right, well, this is my adjacent side. This is my hypotenuse. So adjacent hypotenuse goes with cos. So I would solve it using cos. I would say cos of the angle, which is 40 degrees, is equal to the adjacent over the hypotenuse. Now, looking at that, the variable is underneath the fraction. The y is underneath. How do you get it out of there? Can't divide by 10, because if you divide by 10, you'll get left with 1 over y, which is still not y on its own. It's not any good to us. So be aware, if the variable is underneath the fraction like this, you're actually going to multiply by the variable. This is usually what we don't do. We usually say leave the variable alone, undo everything else that's happening. But when the variable is in the denominator, you need to get it out of there. So to do that, you multiply by y, or the variable, on both sides. So they cancel. I get y times cos 40 is equal to 10. And then I have to divide by cos 40 on both sides to get y on its own. So now it just becomes a regular algebra problem. So you get y is equal to 10 over cos 40. And that now goes into our calculator. So 10 divided by cos 40. A little side note, every time you do a trig function on a calculator, it will open up a parenthesis for you. So like if I hit cos, it immediately opens a parenthesis. I type 40. I need you to make sure that you close those parentheses on your calculator. You don't have to do it every single time. Most times it's not necessary, but there are times where if you don't close it, say like you multiply by 10 afterwards, order of operations, it may do 40 times 10 first and then apply cos function, which you don't want. So general rule of thumb, close your trig functions when you're done with them. All right, and we get 13.054 or 13.05. So 13.05, and we had 8.39. If you check that using Pythagoras' theorem, so 10 squared plus 8.39 squared plus 13.05 squared, it will almost perfectly be equal. We did a little bit of rounding, so there's a little bit of error in there, but it will almost be perfect. All right, guys, your turn. Take a shot at this. Both of these are going to be tan functions, so SOH CAH TOA. We are just using tan for this one. So once again, you're given opposite and adjacent, and opposite and adjacent. I want you to try and solve for the value of x in both of these, and then come back and see how you did. Okay, so tan is equal to the opposite divided by the adjacent. So tan of the angle, and the angle in our case is 30 degrees, is equal to x over 9. To get x on its own, I'm going to multiply by 9 on both sides. Cancel over here. So 9 times tan of 30 is equal to x. So 9 times tan of 30 is 5.196, which would round to be 5.20. Okay, pretty straightforward, right? The second one, tan again, because it's still opposite and adjacent. Tan of 50 degrees is equal to 6 over x. This is one of those scenarios where the x is underneath the fraction. So multiply by x on both sides. And then, so they cancel. And then we've got x times tan 50 is equal to 6. Divide by that tan 50 on both sides. And you get 6 divided by tan 50 is equal to x. So 6 divided by tan of 50 is 5.03. That's a terrible x. X is equal to 5.03, and the next digit was 4, which is just going to be 5.03. Should be good to go. Okay, guys, same idea, but you're going to solve for x, and it's not tan this time. So now you have to figure out which function is it. So we've got SOH CAH TOA, and I want you to take a shot now. Can you figure out which function you need to use? So is it sine, cos, or tan? Set it up and then solve it, and then come back and see how you did. Okay, so first one, angle is up here, which means that 8 is the opposite, x is the hypotenuse. So O and H go with sine. So sine of 42 is equal to 8 over x. So in this one, the x is underneath the function, or under the fraction, I'm sorry. Multiply by x on both sides. And then divide by sine 42 on both sides. So we get x is equal to 8 divided by sine of 42. So let's see, 8 divided by sine 42 is 11.96. All right, so that's the first one. So you had to identify which two sides you have. So we have the 8, we're looking for the x, that's the opposite and hypotenuse. That means we use our sine function. Second one, we've got 25 down here. The adjacent is x, and the 4 is the hypotenuse. So this is cos function. So cos 25 is equal to adjacent over hypotenuse. Now this is an easier one because the x is above the line, so all we have to do is multiply by 4 on both sides. And 4 times cos 25 is going to be our solution. And that is 3.625 or 3.63 is x. So hopefully that's looking okay for you guys. Nothing too crazy there. Moving into inverse functions, these are going to be used to solve for missing angles. So if you type tan 30 in your calculator, what do you get? So tan of 30. So a long decimal should be 0.577350, blah, blah, blah. So irrational number goes whatever. So now, if we had a triangle where 30 degrees was the angle, if we do what's called tan inverse, now where is that? On a TI calculator, you've got that tan button. It's located above it. So usually you have to use like a second function or a shift button to get to the tan inverse. On a phone, particularly an iPhone, I think there is a second function button that you hit, and then the original tan button turns into a tan inverse button. So just be aware of that. So if we do tan inverse. Now, if you hit second function and that negative button on the bottom, which basically gives you the previous answer, so you just drag the previous answer in there, you will get 30 degrees back again. So what an inverse function does is it takes the proportions of the two sides. So tan 30 gave us that 0.577. So that means when I take the opposite side divided by the adjacent, I will get 0.577. If I do tan inverse of that, so tan inverse of 0.577, so the opposite and adjacent are dividing in this ratio, tan inverse would tell me, oh, well, the angle must have been 30 degrees then. So we're going to use inverse functions to find angles, regular sine, cos, tan to solve for missing sides. So that's kind of the key part here. So inverse for angles, regular for sides, depending on what you're solving. So that's your kind of general rule of thumb. All right, so where does that come from? If you think sine of theta is opposite divided by hypotenuse, and I said, okay, well, we know the opposite, we know the hypotenuse, but we don't know the angle. I need you to solve for the angle. You'd say, all right, well, I gotta get the angle on its own. Sine is not something that you just divide by. So it's a function, and hopefully you guys remember that if you want to undo a function, the opposite of a function is an inverse function. So an inverse function is you're undoing whatever it was. So in Algebra 1, you should have had f of x, and then if you want to get the inverse of it, so that'll be f inverse of x, you had to undo, like it was a four-step process, undo everything that was happening in the original function. So you do the reverse of it. So you reverse the process. In this one, say like you want to undo it. So you're multiplying by this function sine. If you do divide by sine, you can't really do that because it's a function. So we think of it instead as laws of exponents. Anything under a fraction can be written as sine to the power of -1 or sine inverse. And if you multiply a function by its inverse, you get 1. You get nothing. It undoes it. It's gone. So in our case, sine inverse times sine will give you just theta. So it's a little bit more background knowledge than what you really need. All I really need you guys to know is that when we get to this scenario and you want to get the angle on its own, you are going to be multiplying by sine inverse on both sides. So you're basically doing sine inverse of that function, and it will cause the two of these to cancel. If you do that on the left-hand side, you must also do it on the right. And the sine inverse is a function, so it's always going to go at the beginning. And it's going to apply to the whole thing. So the sine inverse of the opposite divided by the hypotenuse is how you would get the angle on its own. So solving for angles, you're going to use inverse functions, solving for sides, regular functions. So here's your cheat sheet of sine, cos, and tan if we were to do the inverse functions for all of those. So sine, SOH CAH TOA, so sine is opposite over hypotenuse, sine inverse of the opposite over hypotenuse will get you the angle, cos, tan. Okay, in this example, we've got SOH CAH TOA, so we still start here. And this is something you should pretty much write on the top of every page. Angle is down to A, which means 6 is my opposite, 10 is my adjacent, which means this is a tan function. So tan of the angle is equal to the opposite divided by adjacent, fill in what I know. So tan of the angle is 6 over 10. I want to get the angle on its own. So I need to solve for the angle. So this is when I'm going to multiply by tan inverse on both sides. So tan and tan inverse will cancel, and I'll get tan inverse of 6 over 10. So it's that whole right-hand side goes inside there. And then you put that in your calculator, and it spits out the degree measurement for you. If you're getting like a negative number or like a really small number again, check that your calculator is actually in degrees and not radians. That's the most common thing to check for errors. Okay, so your turn take a shot at these. You're solving for the angle this time and figure out which function it is. So once again, SOH CAH TOA, top of your page. Come back, let's see how you did. All right, first one, opposite, adjacent again. So these are both tan problems. So tan of the angle is 12 over 18. We're going to multiply by tan inverse on both sides, so those will cancel. So it's going to be theta is tan inverse of 12 over 18. That's when the calculator comes out. And that's 33.69. Second one, angles given to us, 7 is the opposite, 3 is the adjacent, still a tan problem. So tan theta is 7 over 3. We're going to multiply by tan inverse on both sides. So theta is tan inverse of 7 over 3. Which is 66.8 degrees. Okay, that brings us to the end of today. So the question, what is trigonometry? Is the study of the relationship between the angles and sides of a triangle. The relationship between the angles and sides is if you take proportions of any two sides, you will be able to solve for a missing angle using sine, cos, or tan. If you're looking for a missing side and you have an angle and a side, again, a combination of sine, cos, tan, and the two pieces of information you know allows you to solve for the third, and that kind of answers the last essential question as well. So for tonight, or for the next 2 days actually, so this is going to do you for Monday and Tuesday, I'm going to assign you some Khan Academies where you're going to practice solving for missing sides and angles using SOH CAH TOA. Even if you get 100% the first time around, I recommend doing the assignment a couple of times. Just make sure that you are really getting comfortable with the different functions, which one you use and when. So like if you're doing it right after this lesson, it's probably pretty fresh. I will come back to it again tomorrow and do it again just to make sure you got it. All right, talk to you guys soon.